Hi geometry students! Today for your asynchronous activity number 3, you will be watching this video to take notes on polygons and area. You can take notes in OneNote or you can use pen and paper. If you use pen and paper, please take a picture of your notes and insert the picture into OneNote. That way you will have a digital copy of your notes in case you lose or ruin the physical paper. Be sure to draw diagrams to help you see and understand the geometry. Being able to see the geometry is half of your success. The more you draw, the more you'll see. Feel free to pause the video at any time for you to write down your notes, or rewatch sections if you didn't catch it the first time. Okay, here we go. A polygon is a many-sided figure where the sides are line segments. The name of a polygon is based on the number of sides, angles, and vertices. Here we have a 6-sided figure. 1, 2, 3, 4, 5, 6, with 6 interior angles. 1, 2, 3, 4, 5, 6, and 6 vertices. So this polygon is called a hexagon. Specifically, this polygon is the hexagon A, B, C, D, E, F, since the vertices are labeled with those letters. Because all of the sides are different lengths, this is called an irregular hexagon. We can show that each side is a different length by marking the sides with different marks. If two sides are the same length, we would mark them with the same mark. So side AB and side BC are the same lengths, according to the marks. This can also be done with marking angles. If angles have different marks, then their measures are different. If they have the same marks, then their measures are the same. So here, angle B and angle D are the same size. Angle C and angle F are the same size. Angle A is not the same as any other angle, and angle E is also not the same. Even if the sides do not look like they are the same length, or the angles do not look like they are the same size, if they are marked with the same markings, then we say they are equal in length or size. This is the great thing about geometry. You don't have to be an artist to get your point across. Your drawing could look wonky, but if you have the correct marks, then it is technically a perfect hexagon, what we call a regular hexagon with equal sides and equal angles. Ta-da! A perfect hexagon is called a regular hexagon because it has all equal sides and all equal angles. A perfect quadrilateral is called a square. It has all equal sides and all 90-degree angles. A perfect triangle is called an equilateral triangle. It has all equal sides and all 60-degree angles. All other perfect polygons have the word regular in front of their names, like a regular octagon, or what some like to call a stop sign-agon. We will mainly be working with polygons with 3 to 10 sides, so learning their names is important. Some people say a heptagon, a 7-sided polygon, is called a septagon, but that is incorrect. Please use the correct term heptagon when referring to a 7-sided polygon. The polygons on the left are all convex polygons, whereas some of the polygons on the right are concave polygons. They are called concave polygons because their sides cave in. This next polygon is my favorite polygon to say, dodecagon. It sounds like a transformer. Do, duo, for 2, deca for 10, dodeca added together for 12. So dodecagon means a 12-sided polygon. This is a concave dodecagon because the sides cave in. And like what many of you researched, it has at least one interior angle that is greater than 180 degrees. What does this even mean? Well, a line is 180 degrees. If an angle opens past the line, then it is greater than 180 degrees. That means all of these interior angles right here are greater than 180 degrees. Because they all open past an imaginary line. This is also a concave equilateral dodecagon because only the sides are equal. Not all the interior angles are equal because we have some interior angles that are greater than 180 degrees, and we have some interior angles that are less. So we have 2 different sizes for interior angles. Because not all the interior angles are equal, this is not a regular dodecagon. It is just an equilateral dodecagon. Here we have an equilateral polygon with equal sides. But what about equal angular? Equal angular is exactly what it says, equal angle. A rectangle is equal angular because it has all 90-degree angles. It is not equilateral because not all sides are equal. This pentagon is also equal angular because all the interior angles are 108 degrees. We cannot say anything about its sides because there are no marks, so we cannot assume whether certain sides are equal. We can only assume it is an irregular, equal angular pentagon. Now, what if we wanted to find the area of these polygons? To find the area of any figure, you must be able to see the figure composed of or made up of triangles and rectangles. You were able to determine the area of my house and your house by finding the area of each rectangular room and adding them together. You can do the same here. This figure is composed of 3 rectangles and 1 triangle. The biggest rectangle has the dimensions 5 by 8.4, so the area is 42. The horizontal rectangle has dimensions 5 by 2, so the area is 10. We don't know the horizontal length of the vertical rectangle, but we can figure that out. Since the horizontal length is part of the horizontal length of the biggest rectangle, we can figure out this length, the missing length, by subtracting 8.4 and 4.8. So that means this length is 3.6. Since the dimension of this vertical rectangle is 3.6 by 4.5, the area of this rectangle is 16.2. Now, how do we find the area of this triangle? Remember, area of a triangle is 1/2 base times height. Since the base of the triangle is the same length as this rectangle, 5, and the height of the triangle is the same length as the height of this bigger rectangle, 5, this means the area of that triangle is half of 25, 5 times 5. Half of 25 is 12.5. So the total area of this figure is 10 plus 12.5 plus 16.2 plus 42, which is 80.7. So when trying to find the area of a weird polygon or a weird figure, just imagine the figure as pieces of rectangles and triangles put together. But how can you remember the formula for the area of a triangle? What if you didn't know that it was 1/2 base times height? The area of a triangle is 1/2 base times height. A triangle is half the size of a rectangle. If you draw out the vertical line and horizontal line from a triangle, you can see that a rectangle was formed. Also, the number of triangles of the same type is doubled to create the rectangle. Therefore, the triangle is half the rectangle, or the different triangles are half the rectangle. So if I draw a vertical line here, and a horizontal line here, and a vertical line here, and a horizontal line here, I have a rectangle that is made of 2 of the same types of triangles. So it is half the size. Again, if I draw a vertical line here and a horizontal line here, I have double this type of triangle. And if I draw a vertical line here and a horizontal line here, I have double this type of triangle. So a rectangle is double a triangle. Therefore, a triangle is half a rectangle. If the area of a rectangle is base times height, then the area of a triangle is half base times height. Thank you for taking notes on polygons and area. I hope you learned some new things today about geometry. Please complete the pear deck to assess your knowledge. Have a good day.